Okay, so yesterday we covered the concept of distance and displacement already. So today, let's go into speed and velocity. So remember that the difference is about scalar and vectors, right? Scalar have magnitude only, vectors have magnitude and direction. So distance and displacement are actually you measuring almost the same thing. Distance you measure in meters or kilometers. Displacement also is meters, kilometers. So I'm just going to add another note here. This one also, right? The example is distance. This one, example displacement, example is distance. So it's like why I put this side by side, because distance and displacement, right? They are kind of like matching. Distance is how far the object travel. Displacement is also how far they travel, but it's how far they travel compared to the original position. Like you don't care what is the total, this like they travel how much, don't care. In the end, you just compare starting and ending point. That's why even though you travel so much, you come back, wow, if you imagine you walk very tired, but you come back to where you started, your displacement, no matter how much you travel, your displacement is only 0. Okay, so distance is scalar. You don't care about the direction, you just plus only. Displacement, we must look at the direction. So when we learn about speed and velocity, right, is a very fancy word. Actually, it is the same thing as speed, but it's the vector version. So I'm gonna do it like this. I'm going to also divide this board into 2. We're going to put speed on one side and then we put velocity on the other. So if you ever get confused, right, if what was this? Just remember, speed is scalar. And velocity is vector. So that means what? That means yesterday you already told me speed you measure as distance over time. Can you give me the unit for speed? Unit. Okay, not wrong. Although I would prefer SI unit, but never mind. Unit, yeah, you can write it. Let me write the bottom bit. Why it's so high? Because I was going to compare here, but never mind. I'll write here. Unit is kilometers per second. Besides that, is there any other unit you know? Besides this number, beside this one, what else? Yes, correct. Meters per second is the SI unit. Yeah, so you focus on meters per second, but it's not wrong lah. You write like that. Okay, so for got a few more lah. I give you one more. Kilometers per hour also can. Now velocity is also the same. The unit is actually the same as speed also. Can also be the same. Kilometers per second can be meters per second, can be kilometers per hour also. But yeah, take note the SI unit lah. This is the SI unit. Okay, this one is the SI unit. My God, I cannot see what's that writing. Let me change the writing to be better looking. This SI unit. Okay, this SI unit. Okay. So the difference here between speed and velocity is that velocity, because it's a vector, if you had to calculate the velocity, okay, if speed is distance over time, speed and velocity are actually the same thing, except one is scalar, the other is vector. So distance is scalar, right? Distance is scalar. That means if you take the vector version, is displacement. So how you count velocity is displacement over time, right? Just bear in mind, right? Okay, that means let's say if you have to calculate the displacement, like let's say in this case lah, let's respect that triangle diagram. So if we have this kind of map, this is the home, okay, this is P, this is the mall, okay, this is the mall, okay, this is P, this is home. So yesterday we already established, right? Okay, if you are moving from home to P to mall, I don't want to go back home lah, because if it's 0, it's very like confusing. So let's say, right, from home go to P to mall, this is 3 km, 4 km. Let's say lah, the time taken is 1 hour. So when you count speed, speed is distance ma. Distance yesterday you already counted for me 7 km. That means you take 7 km divide by 1 hour, it will be 7 km per hour. But when you calculate displacement pula, when you calculate velocity, you take displacement. So displacement, you counted for me already is 5 km. So it's 5 km over how much time? The time doesn't change, because memang you take 1 hour ma, memang if you really actually take 1 hour to go from here to here to here. It's I don't think but the displacement is 5. Yeah, it's 5. But the fact is from home to P to mall you took 1 hour. So your time stays the same. So end up your velocity is 5 km per hour. If displacement is 0, velocity is 0 lor, because 0 divided by something else are all 0. Can follow so far? Okay. So this is one thing you must consider. Another thing to consider is this. If you have two objects, let's say both of them move with the same speed, but this one is going this way 60 kilometers. I put it because I'm thinking of a car. We keep it simple lah. 1 meter per second. This one is going to the right, going to the left 1 meter per second. Now, both objects have the same speed, but they're going in opposite directions. So remember I told you we take positive and negative. Positive and negative can represent the direction, right? So both objects have the same speed. But what do you think about the velocity? Do you think they have the same velocity? Do you think they have the same velocity? You think yes? Velocity is a vector. Velocity as a vector means what? A vector means that it has magnitude and direction. So you see both of them have the same magnitude. Do they have the same direction? No. Because they have different direction, they have different speed. They have different speed. Because they have different direction, they have different velocity. Sorry, my Actually, I'm not feeling well today. So my brain not so sharp. I forgot what I just said. Because they have different directions, they have different velocities. They have different velocity. Okay? Because vector, you must remember, whenever you see the word vector, means got direction. Velocity is a vector. Speed, you don't care the direction. Velocity, you must look at the direction. So sometimes how we can write the velocity, like for the blue object, you can take going to the right as positive. So we actually can write this as positive 1 meters per second. The red object is going opposite direction, it's going to the left. So you can take velocity as -1. So positive and negative already means different direction, no? So different velocity, no? Different velocity. It cannot be the same, positive 1, negative 1 is not the same. Can understand? Okay, just seeing your book, they explain some things is a bit confusing. Okay, so why we learn so much about velocity and not speed? Because now the direction is important. Because if you only look at speed, the thing is, imagine now, why is the direction important? Because imagine if we say, okay, these two objects from the moment we start the stopwatch, release, pom, it go in opposite direction. So they go in opposite direction. Then you say, okay, after 10 seconds, are they at the same position? Now, if you just know, oh, they travel at 1 meters per second, yeah, end up same position. But in reality, no, because they're going in opposite direction, obviously must end up different location, even if the same speed, they will have different results. So for now in physics, year 10, this chapter, we are focusing on velocity. We don't focus on speed. So again, if ever you're thinking, hey, what is velocity? I forgot. You just remember, velocity is like speed, but got direction. Okay, so velocity is like speed, but got direction. And this is important because later you'll be learning about things like collision. When they collide with each other, okay, how's the result? Because if they're traveling together and then hit, it's different result from hit on. It's very different result because the directions are very important. So head on like this is always worse compared to that. Okay. So we will be learning about that. That's why it's important to take note of the positive and the negative. So from this point forth, but then the questions is a bit different. You just be aware of the difference between speed and velocity. Okay. Any questions up to this point? No, okay. Okay, so the next part, we'll just learn one more thing. Then I want you to do some questions already. Okay, so the next part, you have to learn a new term called acceleration. But I think you learned before. Have you learned acceleration before? Have you seen this term before? Have you learned before? Forgot. Acceleration is the change in velocity over time. Change in velocity over time. That means not two objects, same object. Let's say you have one object that is moving. Let's say it starts moving. So when it starts to move, the time, not start to move lah. At first it's not moving, not moving. So when it's not moving, that means the speed is 0. Then it starts to move. Let's say it move, and then it becomes, it managed to reach the speed of, let's say, not speed of velocity, reach the velocity of, let's say, 10 meters per second, then it takes 3 seconds to get there. You know, what's such a horrible number? 5 seconds to get there. So to calculate the acceleration, the change in velocity means what? How's the velocity changing? So normally, this one, we call this the initial velocity because it's starting, the initial velocity means the starting velocity. Usually the symbol is U. Whereas this is the last velocity, right? That's why we call it the final velocity. Usually we use a symbol V. Then time is, of course, T. So another way to write the formula, we write like that. A is acceleration. Change in velocity is how much the velocity change. It's the final velocity minus the initial velocity divided by the time. Now, we will focus on SI units. So that's why I use meters per second. Okay, so velocity is meters per second. So then if you look at the formula, on top is meters per second, and underneath is second. Meters per second divided by second. That means the acceleration unit is m/s squared. So the unit for acceleration is meters per second squared because of the formula. So if you see this, you feel a bit weird, it's correct one. It's m/s2, okay? So meters per second squared, that is the unit for acceleration. So when you want to calculate the acceleration, it's very easy. You just take the number and substitute v minus u over t, right? So v is 10 So 10 minus 0 divided by 5, you count, you get 2 meters per second squared. That is the acceleration of this object. Okay, so acceleration, what is acceleration? So acceleration just means how much the velocity changes every second. It's like, if let's say you can have two objects that are moving, but let's say, right, okay, let's say both objects are moving, same direction Let's say also same velocity So let's say the initial velocity is 0 for both. So I put U get used to the symbol so that you're familiar with the symbol. So if V is the final velocity, let's say both also reach 10. But then one go faster than another. Like let's say you have two objects you release. And then one you push very fast, one you release slow. Like bowling ball Okay. So let's say this one takes the time. They say this is very fast. Wow, 1 second can reach there so fast. This one you slow release, 10 seconds. Wow, really go slowly reach there. So both have the same initial, both can reach the same final, but then the time taken one is very fast, the other one is very slow. It's like, imagine let's say people at the traffic light, the car at the traffic light. Let's say this is a car, okay? People driving. This is special car, round car, and people driving the car. Okay. So this one, the moment the red light turns to green, ting, become green. Now then this one, wow, in a hurry, like, oh, I'm late for work. So drive very fast. Slam on the accelerator, wow, go very fast. Okay. So he can reach there in 1 second, the 10 meters. But this one, let's say the auntie finish shopping, drive safe, don't want to drive so fast, drive so slow. 10 seconds. Can reach the same final velocity, but reach there in 10 seconds. Acceleration is not how fast the object is moving. Acceleration is how fast can reach that one. So they like, vroom, very fast, or slowly, then eventually become fast. That's acceleration. Acceleration is not how fast the object is going. Okay, acceleration. I better write proper English. Acceleration is not how fast the object is moving. Acceleration is how quickly the velocity is changing. Okay, clear about the difference? Between velocity and acceleration. Kind of understand what's acceleration? Okay, up to here first, because the next part you really need to know this. I want you to do some questions. Okay, so acceleration is also a vector. So acceleration is how fast the velocity is changing, right? Now, if the acceleration is positive, it means it's increasing. I better write down, better type it out, not write it down. If A is positive, means that the velocity is increasing. If A is negative, means the velocity is decreasing. That means that it dropped from 10, dropped to 0. So a positive acceleration, normally we call this acceleration. But if it's negative, there's a special name for it. We call it deceleration. Or if you see in the question, they say retardation. Actually, that's what deceleration means. Deceleration is also known as retardation, just to let you know. So that means like positive acceleration is example, right? Like in this question, this situation, the example is it increased from 0, increased to 10. But retardation or deceleration means it's slowing down. Like 10 drop down to 0. Doesn't have to be 0, can be like 5 to 10, 20 to 40, or can be like, if decreasing, right, it's 20 drop to 10, 50 drop to 49, it's decreasing. So this is just the different name lah. Okay, just for you to know. So I think you can try, can you understand or not the negative and positive? So that means acceleration is increasing, getting faster and faster, whereas in deceleration negative means it's slowing down. Okay, can